we are back with the second part of 10.2 arithmetic sequences and series. The first video talked about sequences. Now we're going to take a look at series. So first we define a series by looking at the sum of finite terms in arithmetic sequence with n terms, and the formula is S sub n. S stands for sum, equals n divided by 2 times a1, which is your first term, plus an, which is your last term. So we should define these. A1 is your first term. An is the last term of said sequence. N is the number of terms in the sequence. S means sum of all of those terms. Okay? Example number 1, finding the sum of a finite arithmetic sequence. Find the sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Now, as much time as it took me to say all of that, we could have saved a lot of time just by using the formula. And of course, you could take a calculator and plug all of this in and add it all together. But what if you had 100 terms to add and not just, I think there are 10 here. Let's count it. This is the first term, second term, third, fourth, fifth, sixth, 7, 8, 9, 10. There are 10 terms here. What if there were 100? Okay, so I'm going to show you how to do this simply by using the formula that we went over just a minute ago. So S sub n is equal to n over 2 times a1 plus a10. So n represents the number of terms that we have. I have 10 terms. So I want to find the sum of the 10 terms. So n is 10. That's what we're going to plug in. 10 divided by 2 times a1 is your first term in the sequence, which is 1. An, or a10, because we are looking for the sum of all 10 terms. Remember, you want the first term and the last term of the sequence. And if n is 10, then I'm looking for the 10th term. The 10th term is 19. Okay, so I have 10 divided by 2 times 1 plus 19. So that's S sub 10 is equal to 10 divided by 2 is 5 times 1 plus 19 is 20. 5 times 20 is 100. So the sum of all 10 of those terms is 100, and you can add all of these in your calculator. Guess what you're going to get? You're still going to get 100. Example number 2, finding the sum of a finite arithmetic sequence. Finite just means it has a certain number of terms that it wants us to find. Okay? Find the sum of integers a from 1 to 100 and b 1 to n. All right, so let's just worry about part A first. All right, so we want to find the sum of 100 terms from 1 to 100. Okay? So let's write this out. 1 plus 2 plus 3 plus 4 plus 5. Who's going to sit there all day and write all of this out all the way out to 100? Not me, but I know that this has to go to 100 terms, okay? All right, so we're going to use our formula instead. S of 100. S sub 100. Okay, n is 100 divided by 2 using the formula up at the top that we covered. A1, which is the first term in our sequence, is 1 plus the last term of our sequence, which is 100. Okay, so now 100 divided by 2 is 50. 1 plus 100 is 101. 50 times 101 is 5,050. Now, if you feel like it, then you can actually write out all of those numbers, and good luck making sure that you have typed it in your calculator correctly in order to add all of them together to get 5,050. Or you can learn how to use the formula and substitute what you need in order to solve the problem. That's all we're doing. All right, so looking at the next example, 1 to n. So just like A, that went from 1 to 100, this is going from 1 to n. N being, we don't know what that number is, but we're going to call it n. All right, so S sub n, because that'll be the number of terms in our sequence, will be n because we don't exactly know. All right, capital N at that. So 1 plus 2 plus 3 plus 4. Again, we have no clue where we're going, but we know that we have to reach the end number, which is n. Okay. So I'm going to set this problem up exactly how we did A. S sub n is equal to, in this case, n is, little n is big N, okay? Because we have n terms divided by 2 times the first term in our sequence is 1 plus the last term in our sequence is a capital N. This is all that we can do to this problem. That is as simplified as it's going to get because we don't know what big N is. We don't exactly know where to stop. All right. Last example, example number 3, finding a partial sum of an arithmetic sequence. Now, all this really tells me when I see the word partial sum is that instead of dealing with a finite sequence, which has a specific set of terms, I'm dealing with an infinite sequence, which means that it continues on forever and ever. And I actually am giving you a stopping place of where I actually want you to stop. And in this case, I want to stop at the 150th term, okay? It could say the 50th partial sum or the 53rd partial sum. It doesn't matter. It doesn't really mean anything other than tell you where to stop. All right, so in this particular sequence, to start off with, I have 5, 16, 27, 38, 49, and it continues on. So I want to you could continue the pattern until you get to the 150th term, or there are 3 steps in this particular problem that you can follow in order to solve your problem. The first step is to find the nth term of the arithmetic sequence. So in other words, I want to find the equation. There are 2 things that you need. You need to know what A1 is, and you need to know what the common difference is. In this particular case, we know what A1 is. A is equal to 5. And why? Because it's the first term in the sequence. All right, to find D, you just need to take 2 numbers in sequence order and find the difference of those 2 terms by taking the last term minus the previous term before it. So in this case, I'm just going to use the first 2 terms of the sequence. So I'm going to take the second term and I'm going to subtract the previous term from it. 16 minus 5 is 11. So A1 is 5, my difference is 11. The format to write in an arithmetic sequence to find the nth term is AN is equal to A1 plus D times N minus 1. All right, so I want to plug in what I know. I know that A1 is 5 plus D, which is 11, times N minus 1. You want to simplify that. You get 5 plus 11N minus 11, and then you want to combine like terms. So my formula is AN is equal to 11N minus 6. Okay, that's the formula. All right, the second thing I want to do is, so remember, in order to find the sum of a series, okay, you need to know what A1 is, and you need to know what the last term of that sequence is. So in this case, I need to know what the 150th term is going to be in this sequence. That's where the formula from step 1 comes in at. Because at step 1, I can find that particular answer for the 150th term. By substituting 150 in for n, I know that 11 times 150 minus 6 will give me the 150th term. So if you have a calculator nearby, you'll put this in your calculator. 11 times 150 is 1650, minus 6 is 1644. Okay. Step 3, find the 150th partial sum. Now step 3 answers the original question that's being asked. Now that you have all the pieces that you need, you know that the sum of n is equal to n divided by 2 times a1 plus a sub n. And in this case, we want to find the sum of 150 terms of the sequence. So substituting 150 divided by 2 times a1, which we know from the information that's given is 5, plus the 150. So the 150th term, which is what we did in step 2, is 1644. Okay, so now we got to simplify a little bit. 150 divided by 2 is 75. 5 plus 1644 is 1649. And then when you multiply 75 times 1649, scoot this up a little bit, you get a sum of 123,675. So if I was to write it all out, if I was to continue on with the sequence that was given above, and I got to the 150th term and add all of those terms up, I would have got my answer would have been 123,675. This is a shortcut way instead of writing it all out. That concludes this lesson.